This seemingly ordinary umbrella is about to shatter everything you thought you knew about physics and chemistry. When it rains, we grab our trusty umbrellas to shield ourselves from the downpour. But did you know that the humble umbrella has a rich history dating back over 4,000 years? In ancient civilizations such as Egypt and China, people used umbrellas not just for rain, but also as symbols of wealth and power. These early umbrellas were made from papyrus, wood, and other materials that were often decorated with intricate designs. But what makes an umbrella truly remarkable is the science behind its design. An umbrella is essentially a pressure vessel that can withstand forces equivalent to a Category 5 hurricane. It's like a tiny, portable sphere that can contain a massive amount of air pressure, all while keeping you dry and comfortable. But that's not the strangest part. The umbrella's canopy is also a perfect example of a concave mirror, focusing the raindrops onto a tiny area. This phenomenon occurs when the raindrops hit the umbrella's surface at a precise angle, creating a mini-convex lens effect. The science behind this is rooted in the laws of optics and the behavior of fluids under pressure. To understand this better, let's imagine a grain of sand containing an entire library of books. That's roughly the scale of the forces at play here. But that's not the only fascinating aspect of umbrellas. When you open an umbrella, the canopy unfolds with a precise combination of torque and leverage, all while maintaining its structural integrity. This is achieved through a delicate balance of materials, design, and physics, making each umbrella a masterpiece of engineering. And then something unexpected happened. Scientists discovered that the umbrella's unique shape and material properties can even affect the surrounding air pressure. This phenomenon is known as the umbrella effect, where the umbrella creates a localized area of low air pressure around it. This effect can even influence the trajectory of nearby raindrops, making the umbrella a tiny, portable weather controller. But that's not the strangest part. The umbrella's canopy is also a perfect example of a non-Newtonian fluid exhibiting strange behavior under different pressures. When you apply force to the canopy, it becomes stiffer and more rigid, but when you release the force, it returns to its original state. This property is known as thixotropy, and it's a key feature of many non-Newtonian fluids, including some types of paint and even blood. The science behind this is rooted in the behavior of molecules under different pressures and temperatures. To understand this better, let's imagine a drop of honey on a plate. When you apply force to it, it becomes more viscous and harder to spread. But that's not the only fascinating aspect of umbrellas. When you close an umbrella, the canopy folds back with a precise combination of torque and leverage, all while maintaining its structural integrity. This is achieved through a delicate balance of materials, design, and physics, making each umbrella a masterpiece of engineering. And then something unexpected happened. Scientists discovered that the umbrella's unique shape and material properties can even affect the surrounding air temperature. This phenomenon is known as the umbrella effect, where the umbrella creates a localized area of temperature change around it. This effect can even influence the surrounding air pressure, making the umbrella a tiny, portable weather controller. But that's not the strangest part. The umbrella's canopy is also a perfect example of a thermal insulator, keeping the surrounding air temperature stable. When you apply heat to the canopy, it becomes more conductive and transfers the heat away from the surrounding area. This property is known as thermal conductivity, and it's a key feature of many materials, including some types of glass and ceramics. The science behind this is rooted in the behavior of molecules under different temperatures and pressures. To understand this better, let's imagine a cup of hot coffee on a table. When you apply a thermal insulator to it, the temperature remains stable for longer. The impact of this phenomenon is significant, as it can affect the surrounding environment in various ways. For example, in areas with high winds, the umbrella effect can even influence the trajectory of nearby objects, making the umbrella a tiny, portable air controller. This phenomenon is not just limited to umbrellas, but can be applied to other objects and materials, making it a valuable area of study for scientists and engineers. In conclusion, the humble umbrella is not just a simple tool for keeping us dry in the rain, but a complex device that showcases the fascinating science behind materials, physics, and engineering. If you found this fascinating, subscribe for more incredible stories like this and explore the amazing world of science and technology. Want more mind-blowing facts? Hit subscribe and join our journey of discovery. Let us know in the comments what fascinates you most about umbrellas and science, and we'll do our best to answer your questions and provide more insights. Want to explore more amazing discoveries? Hit subscribe and join our community.